Good morning, everyone. I just want to start the presentation for my internship for the INLS 793 class. And my name is Randall Blanco. I work in the School of Medicine here at UNC, basically working with perinatal data. So that's data that we get from mainly Epic, and it's mom, baby, and fetus data. And that data is used for quality improvement, process improvement, patient safety, patient care, and research. And I have been working with Dr. Alison Stubbe. She is co-director of the Center for Maternal and Infant Health. She's also a professor of OBGYN. She belongs to the division of the MFM, Maternal Fetal Medicine, under the School of Medicine. And my advisor for this internship was Dr. Mostafa. And I'm just going to present what we have been doing and the way I have been extracting data to improve outcomes. Let me start with this data pyramid. Maybe this is something you're already familiar with, but basically we have a lot of data around. There has been a huge explosion of data, and sometimes it's just hard to get information, knowledge, or wisdom out of that data. So we use different tools to not only get the data first, but also to start doing some ETL, extract, transform, and load operations, so we can derive data elements that are not maybe readily available at the transactional or relational models. And then with that derived data, we can infer, better information. Then we can apply business intelligence using more dimensional data models. We can apply data visualization to get some data insights, and then analytics to get into knowledge and wisdom. So that's kind of the north that we usually take when we are moving from data to information, knowledge, and wisdom. Here I'm presenting the initial state that we got when I started this project. We had basically, if you see on the left upper corner, you see Epic users, and they are interacting with the Epic Hyperspace. Those are the screens that the clinicians use to communicate with Epic. And they enter data that way. They get to see the medical records and all of that using the Epic Hyperspace. Every information they update goes into the Epic Chronicles, and that's hierarchical database. And then every day at midnight, Epic Chronicles creates a relational database, or like 40,000 tables that are basically called Epic Clarity. And from Clarity, it's a relational database. Here at UNC, it's a Microsoft SQL Server database. I mean, it has also the capability of running in Oracle. And then out of Epic Clarity, there are some universes created, and those universes are accessed via business objects. We have also, you can see these data abstractors that we had. There were 3 nurses that were basically reading medical records from Epic, and they were typing the same information they were reading into a perinatal database. So this was very inefficient process, because that perinatal database that you see on the lower side was not available to everybody. It was basically disconnected from Epic. So that's how I started working with this environment. These perinatal data quality nurses, they typed information from Epic into this legacy database. So like I said, this was inefficient way of doing things because, you know, there is a lot of retyping, and also this legacy database was not available to everybody in the system. We also had issues with the medical record, like issues where, for instance, I work with deliveries. So sometimes a woman will come to the hospital, have a C-section, but it was not specified what type of C-section she had. So like a classical C-section goes kind of vertical from your belly down. And if a woman has a classical C-section, then if she comes again for another delivery, then we need to do a C-section because she will not be able to do vaginal delivery. But if the C-section is something like a low transverse, sometimes called the bikini C-section, then if the woman comes again for delivery, then the option is there for a vaginal delivery if she had a low transverse C-section. So the C-section type is very important. And we had all the records when I started looking into Epic were basically C-section unspecified. So a lot of people were saying, well, maybe the clinicians are not specifying the right field. Maybe they are sometimes busy, or sometimes that they are not paying all the attention and they are forgetting to put the type of C-section. So what I did is I went to the hospital and I saw exactly the hyperspace screen that was using Epic. And I would talk with the nurses at the labor and delivery 4th floor here at the UNC hospital, at the women's hospital. And I saw that basically clinicians didn't have a way to specify the type of C-section. They only had a way to say C-section, but they could not specify what type of C-section. So just doing this little exercise where you go and do some contextual design to see what is going on really at the data capture, you can figure out that sometimes the data quality is not there, not because people using the system don't want to include all the quality they could, but it's because the system is preventing from getting the level of granularity that you want for that specific data field. So then what we did basically was concentrate on how we could improve the overall quality on the medical record. So one thing, and you know, this is kind of busy, but one thing we did is we said, well, these perinatal data quality nurses, they're not going to type information anymore to this perinatal database that nobody can access, but they're going to update the record in Epic Chronicles. So if they see something wrong that needs to be updated, they will do that, and then that information will be updated into the Epic Chronicles or live system using Epic Hyperspace. That way, that information cascades to the entire system and is not going to be just under this perinatal database where nobody can really see it. Another thing we did is, in that example that I provided where the clinicians didn't have an option to select what type of C-section they were having, we had to change the Epic Hyperspace. I mean, changing data capture improves data quality. So when I said, how can we change this in Epic? Basically, I got from the UNC Epic folks, we cannot do any changes unless they are approved by all hospitals. Because, you know, it's not just UNC, but also we have other hospitals as part of the UNC healthcare system, like Pardee and Nash, Caldwell, etc. So we created an OB-CEF, OB for obstetrics, and CEF is the Council of Epic Flows. So now we meet twice a month and we discuss changes that we need to do in Epic Hyperspace, and then we get approval from an OB perspective from all hospitals in the system for those changes to be made. And with that approval, we can go to Epic at UNC and say, now I have the approval of all hospitals, and please go ahead and change this screen in Hyperspace. So we Dr. Stubbe, Alison Stubbe, and I, we started the OBSEF in August 2018. And since then, like I said, we meet twice a month, and we have made like roughly 30 changes in Epic Hyperspace. And again, all of this is just to improve the quality of the medical record. Improving data capture, you improve data quality. So sometimes you need to get out of your desk and do contextual design to talk with the users and see what is going on. And sometimes you also need to start creating these kind of consoles to provide some data governance and also to make changes into the system. Because I mean, if you stay in your desk and just work with tables and writing maybe SQL code or SQL code, there is not a lot that you can do. So you really need to start working on collaborations, doing contextual design, and then talking with people. All right, so the big actor here on this presentation is the perinatal snapshot. Is the one that shows up in yellow. And like I said, it's just a snapshot. We didn't want on this strategy to create another database, because the minute you create a database, now you need to have servers, you need to have people maintaining the database, etc. So what basically we do is we just go to the universes and extract data. And it's a snapshot. The data is as good as when we did the extract. So if I did an extract this morning, the data will be good as of midnight yesterday. And it's a snapshot. So I don't need to worry about even storing this data, because I can go ahead and rerun this snapshot again, and I have the data again. So what we do with that is we start creating, we start to basically obtain derived data elements, and then we create like a complete data set for different times when women come to the hospital within their pregnancy. So we have like prenatal data set, we have a delivery data set, postpartum data set. We're thinking of doing a lactation data set. We're also looking now into a data set for infants from 0 to 2 years old, and another data set for children from like 2 years old up to 18. So having those data sets and having ways that you can connect them then allows us to basically look at a patient from a longitudinal perspective, and not just on a very specific time when they came to the hospital. An example may be aneurysm in children. So that's something that doesn't happen just because the kid or the child ate something the morning when he or she had the aneurysm. It's most likely that is related with the upbringing of that child, and maybe even some elements during the pregnancy when mom was having the child. So we can look into prenatal records, delivery records, the infant records, and also the child record. So we can go back and analyze what kind of elements are there that may be elements that will help to predict aneurysm, just as an example. Another example for how we use this data is postpartum hemorrhage. So we can look at what variables were there in the delivery, and maybe even before that as a prenatal visits, and understand those variables and see if we can create a model that will predict the likelihood of this mother to have a postpartum hemorrhage. And that's big because with that model, then we can monitor closely those patients that are a high risk, or providing, or the model is identifying them as high risk for postpartum hemorrhage. And then with that data, you can basically run machine learning algorithms to create that algorithm, and then or model, and then use that model to predict whether or not those patients are going to have postpartum hemorrhage. A lot of these data insights you can get using data visualization. So we use these data sets and we connect them to Tableau, and then we can present data visualization, and those data visualizations will typically provide good data insight. Again, this is just OBSEF, what we did, and the hospitals that are represented in this console. So again, I want to emphasize the point that as a data scientist, you cannot just stay in your desk and say, all I have is tables and all I do is SQL and maybe machine learning and data visualizations. And if the data is not as I want it, then I cannot do much about it. I mean, you can do things to improve in your organization, in your environment, the quality of the data that you're going to get. I just want to touch base a little bit on granularities for this perinatal data. So I can look at granularities, just say deliveries. So if mom is pregnant and she had twins, like you can see on the top there, maybe one of those babies was born through vaginal delivery and the other one was like a C-section. So in this case, if I go deliveries, I have 4. If I go pregnancies, I have 3 pregnancies. I have 3 women. Let's say this woman actually is the same person, so I will have just 1 woman having 3 pregnancies, 4 deliveries. So you have different granularities, and you just need to consider that when you are working on your data sets. So if you work on a pregnancy data set, maybe the pregnancy delivery method will be the one that provides more morbidity to mom. So if mom had twins and she had 1 vaginal and 1 C-section, that pregnancy delivery method will be C-section. But when you see the baby, so you pick up the method that the baby was delivered. So maybe the first twin was delivered via vaginal, and the second twin was delivered C-section. So you pick up those values. So you start to see some of these details as you get more into data. So I think our strategy contemplated different aspects. One is this OBSEF, the console for Epic flows. And this is just a way of making sure that we can basically improve data capture so we can improve data quality. We also have humans, or these nurses, that are reviewing the medical records, and they basically update the medical records. They don't update notes, they only update discrete fields. And those discrete fields are updated according to the notes. So what these nurses do is they look at the notes on the medical record, and they make sure that the discrete fields on the database reflect what the notes are saying, and then they can basically confirm that, because at the end, we are basically deriving these data fields out of these discrete fields in the medical record. We're not using natural language processing on notes at this point. I think maybe later on we will, when natural language processing it's more readily available as a tool to us here in the School of Medicine, but right now I only can go by discrete data elements. Again, we created a perinatal universe. So we spoke with Epic at UNC, and then we said these are the requirements we would like to have as SAP Business Objects Universe. So they created one for us, and then we have this with specific data granularities and so on. We work on this integrated data snapshot. So this is just created from different data sources and is used for data visualizations. We also standardize perinatal metrics to ensure that common goals and reports are generated, so everybody's like looking at the same granularities and same reports, and they can talk the same language. And again, we use Tableau for data visualization, so we can report metrics and also explore data insights. In terms of elements of success for this data strategy, I think contextual design is maybe one that is up on top. You really need to get involved. You really need to get involved with the users, the clinicians, understand how the data flows, where the data is collected, and how the data finally ends on the tables. Because if you just work from behind the scenes, looking at the data elements and just from the tables, there is not much that you're going to be able to contribute to improve the system. You really need to go to the front line where the bullets are zinging, if you will, you know, where people are really entering data. And then you need to find out ways that you can basically contribute to improve this data capture. So then the better data capture you get, then you're getting more data quality. And at the end, the data quality is very important because then you can get quality data insights. We recognize in this case Epic as the single source of truth. That's the reason we do snapshots. We don't create new databases. You may be working in an area where maybe there is a customer relation management system. So the CRM may be the single source of truth for you, or maybe one of those ticket systems if you're working on analyzing data from a ticket system perspective for a big company. So you just need to make sure that you know and you understand where is the system that is going to be categorized as the single source of truth. And you need to work on improving how data gets entered into that system. And you need to get into contextual design into that system so you can definitely do some traction and people will recognize around you that you're not just a technical data person, but you're also a data steward and somebody that can have more impact on the whole system. I think it's important, another element of success is to have a team where you have the data analysts and the clinicians. Again, if you work in a company where they're doing cars, the clinicians are not going to be clinicians, but they're going to be the mechanics or the designers of the cars, or you know, those experts. In our case, the experts are clinicians. So I work basically very closely with Dr. Alison Stubbe and a lot of the maternal fetal medicine MDs, medical doctors there. So I really understand what they're looking for. I really understand the research that they're interested, or I understand also, I work with quality improvement folks at the hospitals. So I understand what kind of QI initiatives are basically driving are the main drivers for them. So I basically find ways that I can improve, you know, or help them on achieving those quality improvement goals. So, but it's important that you work with the experts. You cannot work in a vacuum and say, because I know machine learning and I know Python, I know SQL, I know Tableau, and I know business objects and, you know, maybe two more R and some other tools, SAS, then I don't need to talk with anybody because I know everything. I mean, it doesn't work like that. You really need to get involved with people, and you really need to engage and then create collaborations. This big point of improving data capture improves data quality. That's key. So you really need to see how the data is entered into the system, and you need to figure out how you can improve that data capture if it's not working for you. So then you can get better data quality later on in your tables. We emphasize the concept of data snapshot instead of a new database. And we use that data snapshot as a source for data visualization. And in this case, this is a strategy that we have. We kind of reassess, we do improvements, we reassess, we kind of keep feeding this cycle of reassess, design, and implement. And then we reassess, design, and implement. So it's a cycle that never ends. Here we put a poster together for just because people were very excited about all the things that were happening in the data space, and now that they could get reports. So we spoke about, we put this poster together and we presented at North Carolina level for like an ACOG presentation, like American College of Obstetrics. And in this case, it's important to explain your users, even if they're MDs or if they're clinicians, explain them what is going on so they also feel part of the system, because they are Epic users and they are also data users. So it's important to engage everyone. Like in this case, these clinicians, they are, like I said, Epic users, they are OBSEF representatives, they are the ones that are going to be using data, they are the ones that are defining metrics the right way. So, they are part of the system. So you really need to explain what you're doing, so then they feel like they can change the world as well. That strategy was something we put together, and that was a true north for us. It took me like 3 months. I mean, I came here in January 2018, so it took us like 3 months to put this strategy in place. But this strategy, like I said, has been changing. So like Epic at UNC now, well, a new element on this strategy is Epic Caboodle. So Epic Caboodle, it's the data warehouse that Epic is creating. I mean, Epic saw that hospitals are struggling on putting the right dimensions for the Epic Clarity data that is derived from Epic Chronicles every day. So since they're the experts, they said, well, we can put that data warehouse and that will benefit then every hospital that is using Epic. And I think it does. So Epic Caboodle is more oriented, it's more oriented towards the user, the clinician. It's more about, it's a dimensional model, but I mean, again, everything is fed from Epic Clarity, which is a relational database. And Epic Caboodle, it's basically creating, it's a data warehouse that is in a RDBMS, in a relational database management system. So here at Epic at UNC, today is like January 27, 2020. So on February 4th, 2020, they're going to basically go into production with the new element called CDWH 3.0. So these are basically views that are collected now from Epic Clarity and Epic Caboodle. And those views, and this is great for somebody like me, now as a user, as a super user, I can go and access these views using SQL. So For me, this is great because SQL, I prefer SQL over business objects. In my case, I can reuse SQL code. So it's much easier for me to extract data using SQL. And the environment they're running these views on is SAP HANA. So also HANA in general is providing much better performance. And again, the access being SQL makes a huge difference. So that's new. Like I said, this is going to happen on February 4th. So it's very new, and I applaud Epic at UNC for taking these steps to make the data more accessible to people like me. I just want to show some of the Tableau dashboards or visualizations that we create. In this case, there is one metric called NTSV. N is for nulliparous, which means the mom is having her very first baby. So she never had a baby before. She never delivered a baby before. So the N is nulliparous. T is for term. That means the baby is not a preemie, so the baby is 37 weeks or more. S is for singleton, so mom is not having twins, but is just having one baby. And V is for vertex presentation, so that baby comes heads down first. So if mom presents as an NTSV denominator, we expect mom to have a vaginal delivery. Everything is poised for her to have a vaginal delivery because it's the first time, she never had a baby before. She has a healthy baby that is term. It's singleton and is coming vertex presentation. So everything is poised for her to deliver the baby vaginally. But for some reason, it went C-section. So this is an airplane that it's about to land in the vaginal land strip, and for some reason at the last minute lands in the C-section land strip. But then we want to understand, okay, why? Why is that happening? We want to see the C-section indications and all kind of things. Now, to derive this metric, you need like 5 different variables because the metric also says the baby should be living. So if it's like a fetal demise or neonatal demise, then it's not going to be part of the denominator. So living is also part of the criteria for this metric. So you have like 5 variables that you need to check. And nurses are basically, we're doing this by hand. So just checking every medical record and see, is mom, the first time that she's delivering, is she term? Is she like singleton? Is she vertex? Did she deliver a living baby? Yes, okay, so let's put this in as a count for denominator. And then let's see if mom had a C-section or not. So that's the numerator. So I mean, like making this metric, it's a little tedious. And sometimes for nurses in the hospitals, they were taking like 40, 50 hours a month just to get monthly metrics. Now with Tableau, you can just get metrics like this by month if you want to, or you can change. You can see I provide some options to the user on the right side where people can say, I want to see this by years. I want to see this, I want to incorporate race and see if we call it raced with ED at the end, with ETH at the end because it combines ethnicity and race. So if the patient identifies herself as Latino, then is Latino and is race otherwise. So here we have race, and you can incorporate that. You can incorporate another variable like induction and see for the moms that were inducted versus the ones were not, are these figures different? All of this is fake data, by the way. I call it Tableau Hospital, so it's not UNC Hospital data. But of course, we're doing the UNC Hospital internally, and we're tracking this because it's part of the QI, quality improvement. There is a goal in the hospital to reduce NTSV or to reduce C-sections in general. So we can have different options here. I can present this metric by race and induction, or I can do it by induction and race. So you have all flexibility with a tool like Tableau. Also, this is another one that there is a group for OBGYNs, and they say, well, if mom comes with kind of these issues like sepsis or shock or develop those issues while she's at the hospital, eclampsia, aneurysm, you can see those numerators on the right, then that's what we call a severe maternal morbidity case. And the hospitals, the QI, the quality folks, they look at these severe maternal morbidity cases on a monthly basis. So we can show which counties women are coming from and which counties are presenting, higher SMMs rates. So like here, I can see that, and again, on severe maternal morbidity, I can see whether this county has been growing or decreasing in terms of the number of moms that are coming with those issues. So we can see those things. UNC teen pregnancies, I can show, this is another dashboard that we create, which are the teen pregnancies that are coming to our hospital. I want to stop here because this is an interesting one that I really like. And I'm going to explain it, and it's going to take like 2 minutes, but then once you see it, you're going to understand what is happening here. Every time a doctor makes a C-section, a clinician, we need to have a C-section indication. We need to know why we are doing the C-section. So it may be that there is cord prolapse. Cord prolapse is the umbilical cord is showing up first. When you see the birth canal, the first thing you see instead of the baby's head is the cord. So that means we need to do C-section because there's no way that the baby can come, because if it comes, it's going to stop the oxygen because it's pushing the cord. So we need to do a C-section in that scenario. Well, nurses have been trained to put as much information as they can, or clinicians in general, in the medical record. In the Epic, there is a field that we say, Epic says, what is the reason that we went for C-section? So I don't want everything that is happening on that delivery. I want to know what is the main reason we went to C-section. Again, clinicians start marking everything they can. So they say, mom is having twins. Mom is having a baby with a big head, macrosomia, or cord prolapse, or is having arrest of dilation, or is having dysfunctional labor. I mean, there are like 17, 18 different things that the clinicians can click for why we're going to C-section. And they go a little crazy, and they try to put as many as they can. And in reality, we were trying to see the main reason that we went for C-section. So I had an MD and said, Randall, I want to do research on this, but the data we get is just all over the place. So I said, okay, I understand that. So I started talking with her, maybe 4 or 5 hours, like 4 or 5 sessions, just trying to understand everything about C-sections and C-section indications. So finally I said, I think we can prioritize some of this. Like, sounds like cord prolapse is king, if you will. If there's a baby that has cord prolapse, I don't really need to know more. That's raison. That's like the main reason that we need to go for C-section. So it's enough reason to go for C-section. I don't need to know the other ones. And she said, you're right. So then we started to create 11 rules to digest, if you will, this all the different combinations that we were getting on the data, because we got like 200 and something different combinations for reasons for going C-section, you know, different combinations, and you can see the numbers there. So then, like this, I'm showing you the second rule, which is actually core prolapse. So if you see kind of in the middle, the left side is showing the C-section indications categories before applying the rule. And on the right, you can see after applying the rule. So if you see core prolapse, it stays core prolapse, but core prolapse with something else, I don't care what it is going to stay, is going to move as core prolapse. So we're kind of cleaning the data without touching the medical record. We're just doing this analysis outside of the medical record. And as we do this analysis, we finish up with less number of categories that the researcher, in this case the MD, can then write a paper, you know, a peer review paper, and say these are the main reasons that our patients are going for C-section. So this is an example where you can basically, without going back and telling all the nurses, hey, you know, well, you need to do that. We need to do education on the nurses and say, we're trying to get the main reason. So don't mark everything. I mean, put the higher priority reason for going to C-section. But we still have all of this data that we can use to generate information. And using these kind of tools, we can do that. I want to show here that you can see nulls for 2016 and 2017. We have a lot of nulls. But 2018 and 2019, we have less number of nulls. And it's funny, here it's showing 74, exactly same number of nulls. That is because we have been concentrating on cleaning, reviewing the medical records 2018 and 2019. So for me, I mean, I think this is an old chart here, but I mean, I can easily tell these perinatal data quality nurses, please review these 74 MRNs, medical record numbers in 2019, read the notes, and then mark the reason we went for C-section. And if you cannot find a reason, then we ask an MD to read the notes, and then we mark one. So you can just work on the ones that are null, but not all the rest. So this is just an example where you can get data insights from data that is not particularly clean. I mean, you're familiar with these table ones. These are the table ones that researchers need for creating papers, and they say this is kind of our population. So it gets broken by race, whether it's C-section or vaginal. So you may have similar table ones if you're doing anesthesia or if you're doing pediatric work, you know, so typical table ones is one of the first things that people put on their peer review papers, because this is a way to explain populations. But then again, we can create a dashboard or a report that shows this just by changing years. I'm changing from 2017 to 2008. So I think new developments, like I mentioned, CDWH 3.0, that is coming. Machine learning to apply data sets to find predictor models for different clinical events. We have doctors. Dr. Stubbe is very active. She's amazing in terms of understanding. I mean, not from a clinician perspective, she's amazing as a clinician, but also she's amazing in terms of with data. So she got involved now on different committees that are talked at the national level, and she's talking with Epic on how to improve the Epic system for the OBGYN space. So this is great. So now we talk directly with the Epic in Wisconsin, in Verona, about things that we can do to improve the patient care in all the world, because Epic is being used everywhere for OB. In terms of challenges, I mean, we still have resources. I mean, like in my case, Dr. Stubby and I are the ones working on this. So I wish I could have, you know, more people, but I don't. So sometimes what we do is we use interns. So if you are interested in this space, I'm just going to advertise, just contact me and we can figure out an internship where you can spend maybe one semester with us. And then you can get involved on some of these data aspects. And again, because I am School of Medicine and we have different institutions here. So, you know, just keep in mind that you need to start creating collaborations or collaborative efforts. So, you know, there are different institutions involved with data. So you have UNC Healthcare, UNC School of Medicine, UNC Hospital, other hospitals, NC Tracks. So, you know, everybody has different silos and rules that they work with. So you really need to make an effort to coordinate, to basically collaborate and explain people what you're doing so they can help you on changing the data and making a difference in the space. So finally, I want to say thanks to Dr. Alison Stubby, because again, she's like a dynamo and she's she just makes a lot of positive change to the environment and is giving, like in my case, I learn a lot from her. She's always open to explain clinical work to me. You know, I'm always welcome to go and talk with nurses and go to the 4th floor on the women's hospital to see labor and delivery happening. So I think that really helps me understand the data and understand why we need to get the right granularity for the data. And also thanks to Dr. Mostafa, because he met with us at the very beginning of my internship with Dr. Stubby and I, and he provided very good insights. And he has been very supportive about this whole project. So I want to also thank Dr. Mostafa, you know, like I said, Dr. Stubby and Dr. Mostafa, thank you. I don't know if we have anybody on the, but if we have questions, I'll be happy to take questions. If not, then thank you again for listening on this presentation. There is my email. If you have any questions, I'll be happy to respond. Okay, thank you.